Welcome to CUST 1137, titled SUSE Rancher on IBM Z and LinuxONE, First-Hand Experiences from Early Adopter Testing. My name is Mike Friesenegger. I am a solutions architect working on the SUSE and IBM Global Partnership. I'm joined by Andrew Gracey and Andy Hartman as co-presenters of this session. Andrew is in SUSE product management and has been very involved in Rancher coming to IBM Z and LinuxONE. Andy is a senior consultant at Mainline Information Systems. Mainline is a SUSE and IBM partner. Here's the agenda for this session. I will start with why Rancher for IBM Z and LinuxONE. Andrew Gracey will focus on the Rancher for S390X products. Just in case you do not know, S390X is the architecture designation for the IBM Z and LinuxONE servers, just like x86_64 is the designation for Intel-based servers. I'll jump back into introducing the early adopter program. Andy Hartman will share his experiences as a Rancher on Z early adopter. And then I will wrap up the early adopter section as well as talk about deploying your first Rancher environment on S390X and also what's next. So let's start about answering why SUSE Rancher for IBM Z and LinuxONE. SUSE was the first to bring enterprise Linux to the mainframe. We have many customers using SUSE Linux Enterprise Server on their IBM Z and LinuxONE systems. These customers have been asking SUSE about our container strategy since Kubernetes started making waves in the industry. It is also important to remember that SUSE innovates everywhere. We focused on multi-architecture enterprise Linux years before our competition. It is important that we do the same for Kubernetes and container orchestration so that customers have choice. In addition, Rancher on IBM Z and LinuxONE allows SUSE to connect the S390X architecture to the SUSE focus in the data center, at the edge, and in the clouds, either public or private. Bringing Kubernetes and container orchestration to S390X made perfect sense when SUSE acquired Rancher in December of 2020. Technically, we proved it worked, but we needed SUSE executive approval to productize. So in early 2021, we presented the business plan, which the SUSE executives approved. It was important that the Rancher products run on any IBM-supported Linux distro on IBM Z and LinuxONE, and I'm excited to say this has become reality. So I'd like to hand off to Andrew so he can present the Rancher products that will run on the S390X architecture. Andrew?
Yeah, thank you. Let's go to the first one. So the first component that we ported over was Rancher Manager, which most people will probably call Rancher outside of the company. This is the Kubernetes management, the multi-cluster management of all of your Kubernetes clusters across your entire infrastructure. We added S390X support in the 2.6.4 release, which was, I believe, in April, if I recall correctly. And we carried that forward into 2.6.5. It's in 2.6.4, we added it as a tech preview, and it's been labeled the same for 2.6.5. And we allow through that, we allow you to host Rancher Manager itself on an S390X based cluster, Kubernetes cluster, but it can manage downstream clusters that are on any architecture. This could be S390X or AMD 64 or ARM eventually. We have validated that the server components itself, along with the Rancher agent, fleet agent, the home catalog, and we as well as the backup and restore operator. Each of these components inside of Rancher do work as intended and work the same as they would on a Intel-based or AMD-based uh, uh, cluster. The things that we have not built for in the 264 release that we are planning on building out and validating in the coming months are monitoring. This would be your Prometheus and Grafana underneath. Logging outside of just the standard Kubernetes logging, which you do get, but any additional logging through the Bonsai Cloud logging operator that hasn't been ported yet. The alerting, CIS scans, Istio, and OPA Gatekeeper. Each of these are still in the works, and will probably come in the order that I just listed them. Would be my guess. The engineers are actively working on that, and we should know more soon. We do have support for running the cluster that runs Rancher Manager and Rancher Manager itself on ZVM, KVM, and directly on LPAR if you need that level of support. The installation is the same as it would be for any other architecture. Actually, almost all of this is very much the same as it would be um, for x86 or ARM. So if you're used to those environments, you should be very pleasantly surprised because we didn't change much. Let's go on to RKE2. So RKE2 is our Rancher Kubernetes engine. This is the data center grade Kubernetes that runs that we can use to run Rancher Manager itself, as well as be a downstream cluster to run all of your workloads. It is a Kubernetes CNCF compliant Kubernetes distribution, and it comes with some nice built-ins by default. Support for S390X was added in v121.8. And then we went on to add 122.9 and 123.6. So you've got across a couple different Kubernetes release streams, we have support for S390X. As we go forward, we will be able to add S390X support as we add future release streams. So when there's Kubernetes 124 and 125 releases, we will be able to match those relatively quickly. Out of the box, the supported CNI, which is the networking interface or container networking interface that we support is Canal. Canal is a combination of calico and flannel. I hope I get this right on the spot, but it gives you the benefits of both. There are other RKE2 supported CNIs that we have not ported to RKE2. If you are interested in those, please let us know, and we can get those on the roadmap. For right now, we are only supporting Canal for RKE2. And similarly, RKE2 comes with Nginx as the default ingress controller that's built in, and we do support that. And we have tested and support on SLES, RHEL, and Ubuntu. So if you are running one of those, or have customers that are running one of those, we can support you. And again, as with Rancher, the installation is exactly the same set of steps as it would be for other architectures. Let's go into K3s. So K3s is our lighter weight Kubernetes. It was originally more of intended for edge scenarios. However, because it is a compliant CNCF compliant Kubernetes distribution, it's actually found a lot of traction in the data center as well. Because it is lightweight, it is very easy to get up and use, and it has some really nice defaults for smaller clusters. This was actually not in our original scope, but after working with a couple of our early adopters, we found that actually it has some nice benefits that allow us to make a couple different architectural decisions on how we actually roll out the Kubernetes and deal with high availability. if you're interested in those architectures, please let us know, and we can talk more about those. But because most of the work that we were already doing for RKE 2 was actually applicable for K3S as well, we put that into scope, and it made a lot of sense to add that in and give that option as well. We added support for S390X in the 122.9 and 123.6 releases of each of those code streams. And again, same with RKE2, the future releases will inherit S390X support by default. On K3S, we support Flannel as the underlying CNI. And for the ingress controller, we support Trafic. And yeah, as well, this is also supported on SLES, RHEL, and Ubuntu. And as with all of this, the installation is the same as it would be for x86 or ARM. And then lastly, we've got Longhorn. Longhorn is our cloud-native distributed persistent storage. It allows us to give all of the clusters in your in your Kubernetes access to persistent storage through the Longhorn storage class. And basically allows you to bubble up all of your all the storage that's inherent on your machines, or that the Linux that is running your node can see, and it allows you to bubble that up from the infrastructure storage into the container storage layer in a highly available and fault tolerant way. We have done the initial build testings based on 1.2.2 of Longhorn. We have tested this with DASD and FCP storage, and then the support is initially planned for SLES only for Longhorn. This is because their storage is weird, and Linux storage is doubly weird. So the goal is that the installation will be the same as all the other architectures, and eventually we will also support RHEL and Ubuntu, as once we know all the drivers that need to be matched. We're hoping for support in the upcoming 1.3.0 release, which might actually be between the time of the recording and the time of this release. So that might be old news by the time you're watching this. And with that, yeah, I'll hand back over to Mike.
All right. Thanks, Andrew. So let's take a moment and talk about early adopter experiences and the early adopter program. We started the early adopter program. Actually, we started talking to customers and partners shortly after SUSE executives approved Rancher coming to S390X. As we talked to those prospective customers and partners, we heard a number of things, and here's just a list of some of the things that we heard. So keep the install as simple as Intel, and hopefully you've heard that from Andrew, but I'm going to repeat it again. That has been a key focus of ours, keeping the install the same as Intel, making it easy. The Rancher components, RKE2, K3S, and Rancher Manager can all be installed online, meaning that that pulls directly from GitHub or Docker Hub to get the bits to be able to deploy. But we heard that air-gapped-based installation support is a requirement. There was a particular customer we're talking to where security was extremely high, and they could not, their networking team did not allow them to access the internet from their Z instances. High availability was also very important, so making sure that we supported a highly available deployment across data centers was critical. Minimal hardware requirements were important to many of our customers and partners that we spoke with, and minimize the processor utilization if possible. They were excited to see, if we could do something to minimize the overhead of the Kubernetes components taking up extra cycles on the Z processors. So in January of 2022, we kicked off the early adopter program. And as part of the program, SUSE provided our early adopter customers and partners several things. First of all, we were still in the pre-release stage, so we had to create a document with a few pre-release notes. But for the most part, that document pointed to the official Rancher documentation for people to follow. Like Andrew said, we wanted to keep the installation the same as as the other architectures. I created several short installation videos for both online and air-gapped based deployments. These videos showed installations both on ZVM and KVM on S390X. And lastly, we tried to connect a local pre-sales engineer as the initial point of contact for any questions or issues as the customer or partner was going through their early adopter testing. So now I'd like to introduce Andy Hartman of Mainline so he can tell you about his experience with Rancher on Z. Andy?
Thanks, Mike. When Mike and I started to discuss Rancher on Z, we talked a lot about making it, as simple to implement on Z as it was on other platforms like x86. And I think that Mike and Andrew and SUSE have done an excellent job in providing a very simple way to install and implement this. In order to test this, I set up an environment we have a business partner innovation center, which is basically, it allows us to demonstrate various products from partners and other vendors, and we do demonstrations for customers and various other things with all this equipment. We have an IBM Z15 TO2 with 5 IFLs, and those IFLs are shared across many LPARs. But to set this environment up, I used a single ZVM LPAR with 64 gig of memory. The system was connected to IBM storage. In this case, it was a DS8K with both traditional ESKD and FCP attached storage. I used just traditional ECKD disk for the Linux and ZVM, the hypervisor. I deployed the Linux servers under ZVM 7.2. They had very simple configurations. I gave each virtual guest 2 virtual CPUs and 8 gig of memory, and about 20 gig of disk space each. All the ZVM and Linux configurations from a hardware standpoint were identical as far as disk space, memory, and virtual processors. I evaluated all 3 supported Linux distributions. I deployed RKE2 and Rancher on SLUZ 15 SP3, RHEL 8.5, and Ubuntu 22.04. Each deployment consisted of 6 Linux servers, all running the same version of SLUZ or RHEL or Ubuntu, whichever one I was testing at the time. I set up one RKE2 cluster consisting of a control node and 2 agent nodes or worker nodes to run Rancher itself. I then set up a separate RKE2 cluster, again consisting of a control node and 2 agent nodes. The second cluster is going to be used to run user applications. In my case here, this is where I ran or I deployed a simple app to test. For any of the 3 Linux distributions, I installed the servers manually. In this case, you could have used automation tools from the distribution, or if you're running under ZVM, you could have used something like IBM Cloud Infrastructure Center or Velocity zPro. In any case, deploying these base servers was very easy and only takes minutes. One of the nice things about deploying RKE2 and Rancher was the lack of a lot of the prereqs. With a lot of Kubernetes installations, there seems to be a large amount of preparation and information you have to gather. In this case, was kept very minimal, which was very nice. When I did the installs for the Linux servers, all the servers were installed with just a base configuration. So just think of a base Linux server, nothing special. As far as as the actual deployment goes, it was very simple. Um, there was, like Mike had indicated, there's small set of instructions, and he put together some excellent videos. I basically deployed this after watching his videos. And the videos are like 5 minutes a piece, and there was only like 4 of them, so very simple to implement. Um, the actual deployment is pretty straightforward. Again, from my experience, I set up the servers, I deployed RKE2, then I installed Helm, which is a package manager, and then I used Helm to deploy Rancher on the first cluster, and then I deployed another RKE2 cluster. After I got that done, I had Rancher connect to the other cluster so it can control it, and at that point I deployed my application on that second cluster. Again, very straightforward, very easy to implement. Not a lot of complicated instructions, and it went very smooth. So very impressed with how easy it is to implement. As far as Rancher itself, I found it to be very intuitive, very easy to understand, easy to deploy applications. I think SUSE has done a great job streamlining her implementation of this, and at this point, I'm very satisfied. Back over to you, Mike.
Right. Yeah, thank you, Andy. That's a great what you said. We absolutely appreciate you taking the time and being one of our early adopters. The test application just was a really simple Hello World application. I created a Hello World container, but a little bit later on in the presentation, I'll give those of you that are interested in trying this out on your own, I'll give you some ideas on how you could create your own containerized application and things like that. So let me jump to the next slide and talk about another early adopter customer, actually, and we met with this early adopter customer in early 2021, shortly after we had the executive approval. And from the meetings, we had a number of meetings where we talked about different evaluation scenarios, and we finally agreed upon 2 evaluation scenarios. This slide shows the diagram for scenario 1. The next slide, which I'll show here in just a moment, will show the diagram for scenario 2. The goals for the first scenario are pretty straightforward. We like Andy, we wanted the early adopter customer to deploy RKE2 for Rancher Manager, and then deploy another RKE2 as the downstream cluster where a test application would be run. The customer had built a in-house test-based microservices application. It needed persistent storage. It was originally developed for Kubernetes on Intel. The application consists of a couple of different containers. One is a database container, which is what needed the persistent storage, as well as a front-end web UI. So basically, to sum it up, this was a relatively easy scenario and has been successfully deployed and tested by the customer. Now let's jump to the second scenario, which we're in the middle of working on right now. But this evaluation scenario, this is a little more complicated. Not too much, but this is where K3S came into the picture, and this customer wanted a highly available setup. And this is where we thought, K3S using a MySQL container for Rancher Manager would provide a highly available setup of the Kubernetes infrastructure spread across multiple data centers. In this case, instead of having one downstream RKE2 cluster for where the app is deployed, this will have 2 RKE2 clusters, one in each data center, and both clusters will use highly available persistent storage. The same application that was deployed in scenario 1 will be deployed on one of the downstream clusters in this diagram. Then we're going to test Rancher Manager fleet operations and confirm that it can fail over the application to the secondary downstream cluster running in the second data center. And like I said, this scenario is being tested. So we're still working on it, but we're making very good progress. Again, this early adopter customer has been great to work with, giving us a lot of great ideas on a number of things, including highly available persistent storage options, taking advantage of Z-based storage paradigms and things. So I mentioned deploying. If you're interested in deploying your first Rancher environment on S390X, you can do that today. You're able to deploy the Rancher for S390X components today if you want to try this. I encourage you to use the published YouTube videos. The videos that Andy spoke about that I had created were for our early adopter partners and customers. We have since, we're preparing, and by the time you watch this, the officially released YouTube videos will be available that will show deploying Rancher products within ZVM and KVM on S390X. You've heard us say multiple times that the installation is the same as other architectures. So I encourage you to use the official Rancher documentation as your key documentation resource. On this page are all the links to all the official Rancher documentation. After you get the basic Rancher RKE2 Rancher Manager components deployed and everything, you probably are going to want to deploy a containerized application. Now, you're welcome to use the Hello World application. I've made some changes to it, but since Andy worked on it, but basically, if you wanted to deploy your own containerized application, you could build that containerized application using SUSE Linux Enterprise base container image, or what we call BCI for short, as a starting point to build your containerized application. The link on this page is to the SLE BCI documentation. If this is the first time you've heard of SUSE publishing and providing supported base container images. If you want to try just using the Hello World, actually what I've done with the Hello World is I've adapted it to using the SLE BCI, whereas Andy's test was using some other base container image at the time that was not SUSE based. Lastly, if you want, I suggest that you consider joining the community, the SUSE Rancher community, as well as the Slack channel, which will allow you to discuss Rancher products in general and also Rancher products in specific that are running on S390X. So wrapping up, what's next? Well, there's a lot of things we really want to do, but for this release of Rancher for IBM Z and LinuxONE, this release is a foundational release, which means that it gives SUSE the foundation to do more within the product and with partners. A key focus is to enable additional capabilities. You heard Andrew talk about the cluster tools in Rancher Manager, like monitoring, backups, CIS benchmarks. Another area that Andrew spoke about is container network infrastructure, or the CNIs. Canal being one of them, and Flannel being the other one. But we'd like to hear if you need additional CNIs, please come talk to us. We want to hear what CNIs are important to your implementation for Kubernetes in your infrastructure. We've already started working with a number of ISVs to enable their containerized applications for Rancher on S390X. The plan is to actually have those applications available in the application portal within Rancher Manager, and that will be the first step in allowing us to enable and create integrated solution stacks that combine the strengths of the IBM Z and LinuxONE server with SUSE Rancher and the containerized applications that are being developed and supported by ISVs. And this will be able to be deployed, whether it be on-prem or in the public cloud, or even in a hybrid configuration on both. So I think, but most importantly, I think it's for us here at SUSE, we are going to continue working with customers and partners and support their journey to application containerization and microservices using Rancher and IBM Z and LinuxONE systems. So with that, I'd like to thank you for your time today and taking the time to learn about Rancher on IBM Z and LinuxONE. Please feel free to reach out to me or Andrew or anyone and ask questions about Rancher on IBM Z and LinuxONE. And as always, enjoy the rest of SUSECON. Thank you very much.